Hello guys, welcome back. In today's video, we will look at what is a source code and how it is converted into a machine code. Later, we will look at the use of compiler and interpreter. After that, we will understand what is a bytecode. And finally, we will understand one of the important features of Java, which is portability. So without wasting time, let's get started. Now let us understand what is a source code. So this is the snippet of our program which we had written in our previous video. So what is a source code? Source code is basically a form of a program which humans can read and write in. So the format which we can understand as a human is nothing but the source code, right? So source code is simply a version of a program which human can read and write in. Now let us understand what is a machine code. So on your screen you can see this zeros and ones. So this is the kind of a format which your computer can understand. And this is simply the called as the binary instruction for the computers, right? So this is what is called as the machine code. So machine code is a version of a program which your computer can understand. All right, and it is usually written in binary format. Okay. Now let us understand what is a compiler. So compiler is simply a program that converts your source code into your machine code, right? Which your CPU can understand, right? But not all compilers generate machine code. Like you have exceptions for like Java compiler, which generates another form of output. And we will discuss this in later part of video, right? But wait, I said compiler is a program itself. If compiler is used to develop programs, then how was your compiler developed, right? So basically it was written or compiled in another language or even in the same language. Like, compiling a compiler with the previous version of itself. So, that's the reason your very first Java compiler was developed in C language, right? So that is it for the compilers. Now let us try to understand the problem with compiled languages like C, C++, and right. So in those languages, if you compile your program and you have your output as a machine code, right? So if you try to copy this machine code and if you try to simply run it on the new system, so it might not work, right? So this could be possible due to different kind of a OS or different processor model, right? So the problem with the simply compiled languages is that that might not work onto the different systems. So if you want to truly run those programs on different versions of the OSS, you simply need to simply share your source code, compile onto that system, or you simply need to build and share the executables for every single platform, right? So that's the problem with just the compiled languages like C, C++. So Java sneaks around its issue very efficiently. So what it does is, after you compile your Java source code, it generates the intermediate file called the bytecode, right? So basically, this is how the bytecode will look like, right? And if you might have noticed, after you compile your Java program, and then you have another file generated, and it has an extension of dot class. So that is nothing but your bytecode. Okay. So you can generate your bytecode in one computer. And if you want, you can later on share this bytecode to the other system. And where if you want to run, you can simply call the interpreter and you can convert it into a machine code for that system. So this is what makes Java portable, and hence Java is called write once, run anywhere, right? So this is the most important feature of Java, which is portability. Finally, let us look at the timeline of Java program execution. First, you write your Java program and save as .java extension. Later, you compile your Java source code using Java C command. The output is a bytecode which has an extension of .class. And finally, you execute your .class file using Java command by providing valid input and verify the expected output. So that is it from today's video. In our next video, we will look at the architecture of Java. And before leaving, please don't forget to like, share, and subscribe. And see you until next time.